Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the autocorrelation function. And this is a example of spectral characteristics of the random process example. This is the previous examination question. The example is the power spectral density of a stationary random process is given by Sxx of omega is equal to A for minus omega is equal to minus k to k and Sxx of omega is equal to 0 otherwise. Find the autocorrelation function. Coming to the solution, given that the power spectral density is Sxx of omega is equal to A for omega is equal to minus k to k and 0 otherwise. So we know that using definition of inverse Fourier transform, the autocorrelation function Rxx of tau is equal f inverse of Sxx of omega is equal 1 by 2 pi integral minus infinity to infinity Sxx of omega into e power j omega tau d omega. So Sxx of omega is applying the given power spectral density into RHS term. So 1 by 2 pi integral minus k to k a e power j omega tau d omega. Sxx of omega is a. So a is constant that is written before integration. A by 2 pi integral minus k to k e power j omega tau d omega. Integral a power j omega tau integration with respect to omega is e power j omega tau by j tau over minus k to k. Now substitute upper value of omega and lower value of omega, we get a by pi t into, so this denominator, this term can be arranged as a by pi tau into 1 by 2j. So when you substitute upper value of omega and lower value of omega, the numerator term is e power j k tau minus e power minus j k tau. So the numerator, this within the bracket term is sine of k tau. So therefore Rx of tau is equal. Now here on RHS side, multiplying numerator and denominator by k, we get ak by pi sine of k tau by kt. Sine of k tau by k tau is the sampling function. So therefore Rx of tau is equal ak by pi into sum of k tau.